Hi dear student, this is Wajid Ali Shah and today we are going to explain and derive an equation for EM ratio. Determination of the EM ratio, which is given on page number 124 in class secondary book. As we know that this is the direction of the magnetic field into the board. Like this. Cross shows the direction of the magnetic field or any direction into the board. Dot shows out of the board. So this is a magnetic field directed into the board. If we throw a charge, a test charge, positive test charge into the field with velocity v, so a force shown by this equation is acting on this charge. What is the direction of the force actually? So velocity v, extend the finger in direction of the v and rotate your finger in direction of the magnetic field into the board. So we can have a force which is acting on the charge in upward direction like this. Okay, so as all the times the force acting on this moving charge in this magnetic field is always perpendicular to v and p, so finally we can have a circular path inside a magnetic field. The charge must be moving in circular path in a magnetic field. Using this concept, we can find charge to mass ratio, which is a technique basically to find the magnitude of charge. So, using this equation and a few more equations, we can find EM ratio. As we know that F is equal to QVB sine theta. For simplicity, we can take maximum force QVB by putting angle 90. In this equation, we can see that this is the maximum force which is acting on this moving charge in a magnetic field. So, this is the same force which makes a circular path for the charge in a magnetic field. So from our previous knowledge, we know that for circular motion, centripetal force is very much important. So the centripetal force in this case is provided by this force. Centripetal force is basically the reason for the circular motion of the charge in a magnetic field. And what is the magnitude of that? What is the reason of that force acting on a charge? It is the force acting on a charge by the magnetic field due to its motion. So, this amount of the force is produced by this reason, making equation 1 equal to equation 2. We can have QVB is equal to mv square divided by r, where Q is used for charge, V for velocity, B magnetic field. On the other side, it is mass of the charge. This is V velocity square divided by R. R is radius of the circle along which the charge should be moving. Cancelling some factors like V from both sides. Here we have v square and it is 1v, it is square of v, so we can cancel 1 on both sides. Or simply we can say that v divided by v, divide both sides by v. Here we cancel, 1 we cancel with the denominator. And finally we have an equation like Q divided by M is equal to V divided by VR. Q is taken equal to E E is a symbol of charge, so we can put this E instead of Q in the equation and can write like E over N is equal to V velocity B R. This is E impression, which is equal to V divided by B R. E divided by M is equal to V divided by B R. This is equation 1. Again, from our previous knowledge, again, we can have that 1 over 2 mv square. The kinetic energy adopted or achieved by the charge is because of this value. Here, there is a difference in small v and capital V. This small v is used for speed and this capital V is used for potential difference. So, finding the value of E from this equation 2. Equation 2 gives us that small v is equal to 2 E capital V divided by M square root. Putting in equation 1, we can have E over M is equal to, put value of V, small v, from this equation into this one. So we can write 2 E V divided by B R square root, and in the denominator we have M, so we can simply write it here like this. It makes no difference if we write this M under the same square root, or we can write another square root for these two different terms. Taking square on both sides, squaring. E square divided by M square is equal to, square root will be cancelled with square, so 2EV divided by B square R square into M. Now we have E square M square on left side and E over M on right side, so we can cancel 1 E with this square, 1 M with this square. So we have E over M is equal to 2 V divided by B square R square. This is an equation used for E-M ratio, where if you know the potential difference applied for the motion of the charge in a magnetic field, if we know the value of the magnetic field, if we know the value of the radius, so we can find E-M ratio, charge to mass ratio, which explains that on how much mass, how much charge is present or can be accumulated. Thank you. Have a nice day.